Hello. Hello. Hello, Helen. Hello. Helen. Nikita. Am I audible? Yes, Nikita, am I audible?
Yes.
Okay, great. So, today you are having a different name?
Yeah.
But I'm not able to see you.
Oh, it's just because I'm just like right now. Like, can you give me a minute?
Sure.
Yeah.
Hello, Helen. Your mic is off. Okay. Hi, how are you doing?
I'm good. How are you?
I'm good. Thank you so much. So, Helen, I haven't received your any test. I mean, like, chemistry test recently I have received. Recently you have submitted your chemistry test. I suppose yesterday, right? Yesterday you did yesterday. Okay, great. So how was the test?
It was okay. But I think I need more practice.
Okay. And what about you, Nikita? Nikita, you're not giving any test? And Ramit?
Well, I mean, I did like tests before, the chemistry test.
Okay, so when you submit?
I already did.
And what about you, Ramit?
I've done it, and the second question was like the big paragraph one was the one that I didn't understand. So I've left that one, but I've done all the others, but I've yet to send it.
Okay. So the remaining one you have sent?
Yeah, I'm gonna send it today.
Okay. So what we'll do in today's class, we'll discuss that, okay? That question. In the last, we'll discuss that question. Okay, Ramit?
Yeah.
Okay. Helen, do you face any problem? Any question? No. Okay. No issue. What we can do, we can discuss that question. We will discuss that question, which exactly is difficult for you. Okay? No issue. And then when I'll check it, then I'll just tell you your mistakes. So Ramit, when you submit it?
Today.
Okay. Fine. No issue. So, Nikita, Helen, and Ramit. Ramit and Nikita, you both are not visible. You both are not visible. You both have to turn on your camera. Yes. Hello. Okay, great.
Hello.
Nice. Finally. Okay. Great. So let's move. In previous class, I have told you about the periodic table, right? I told you about the different laws. Mendeleev periodic law, Morton periodic law, Newland's law of octave, which was really helpful to understand the concept of periodic table. How and why we prepared our periodic table. Why it was too important. Right, Helen? Okay. So we have done that in the previous class. In today's class, which is a very important topic, trends. We are going to discuss the trends in today's class. Okay? That means if I say about the periodic table, which factor really affects in making the periodic table? So in today's class, basically we focus on the factors which exactly affect the periodic table. So first of all, the factors, to understand that factors, we have to take a group. The first group is known as alkali metal. So, what we do in today's class? In today's class, initially we understand the concept of periodic table. There will be a few points I tell you about that. Then we go for alkali metals and its physical and the chemical property. These are the three topics which exactly we have to cover in this class. Okay? Okay, Ramit?
Yeah.
Yes. I hope you all are able to see the periodic table. In the periodic table, you can see that groups and the periods. These are the groups. Vertical one is known as group. And the horizontal one is known as a period. So if you count that, 1, 2, 3, 4, 5, and 6. But there is one more because hydrogen placed here. So we can see 7. So in total you can count 7 groups are there. Right? You can observe that. It means we can say here the period 1, the period 2, the period 3, 4, 5, 6, 7, 3. So what we can observe, see, as I told you, groups are a vertical one, right? So we have to count how many groups are there. You can see it here. If you will count group number 1, okay? Group number 2, this is group number 1, this is group number 2, right? 3, 4, 5, 6, 7, and 0. Okay? These are known as groups. Okay, Helen? Okay, Ramit?
Yeah.
If I say about the periods, right? You have to count it like this because it's a horizontal one. The period 1 is for where hydrogen is placed. Period 2, 3, 4, 5, 6, and 7. 7 periods are there. Right? Do you understand this one? Okay. In total, we have these groups also, but we'll just count it later. Okay? What we can do, how we can classify that? The group number 1 is known as alkali metal. Do you know that? Do you know that group 1 is known as alkali metal?
Yeah.
Okay. What is the name of group number 2? Tell me, what's the name of group number 2? Anyone?
I forgot.
Okay. Helen?
Is it alkaline metals?
Exactly. It's alkaline earth metal. Okay? If I say about the group 0, what's the name of group 0?
Noble gases.
Yes, noble gases.
I thought the noble gases were group 7.
No. Group 7 is known as halogen. Group 6 is known as chalcogen.
What does that mean? Chalcogen.
It means it forms ore.
Okay.
Okay. Ram, are you busy somewhere? Where?
I'm not busy.
Okay. Group 5 is pictogen. Okay? These are the groups. Group 1, Group 2, Group 5, Group 6, Group 7, Group 0. These are the specific names which is exactly applicable for all the groups. Okay? For instance, you can see that Why group 0 is known as noble gas? Because it's stable, right? Because it is stable. Stable means it doesn't react. These are the perfect one. These are like a god. They never fight. They never react. That's how we can see that. We can see these are perfect. They are known as noble gases. As if I write the electronic configuration of neon, the atomic number of neon is 10, right? So if it's 10, you can write 2, 8. Am I correct? Yes. If I say about the argon, it would be 2, 8, 8. Right? If I say about the krypton, it would be 2, 8, 8, 18. Like that. So what are you observing in the last shell? Last shell is completely filled, right? 8, 8, 18. So it means it will not react with any one. That's why I can say that it is very stable. What's going on? Ramit? What happened? You want to say something?
No. Why?
No, I'm just asking. Nothing else. Okay. What happened, Nikki? You're very happy?
No, it's just that the way Ramit just made it was so hilarious.
Okay. So now Ramit will tell me what I have explained.
You explained the different groups and the names of the groups.
Okay.
Mm-hmm.
And the last one, which I explained?
Yeah, you explained the like the shows, like 2, 8, 8, and then 16, 16, like that.
It was 18.
Yeah, 18. Yeah, that's what I said.
And why was I explaining that?
To find out how much goes into what goes into what, like all ones. You said 2, 8, 8, like that.
Okay. Helen? Is Ramit saying correct?
Yeah, I think so.
Okay. And what about you, Nikki?
Totally.
Actually, you all were not going to focus here. Right? You don't know what exactly I'm explaining. Way back. I was explaining about the noble gases. These are the electronic configuration of noble gases. I was saying noble gases are perfect, stable. It never reacts with anyone because its octet is completed. Right, Ramit?
Yeah.
Okay. So its octet is completed. So we can say that here, that's why it is known as noble gas. It doesn't react with anyone. If I say about the group 7, it is known as halogen. Are you guys writing it somewhere? Please make few points. Okay. Okay. If I say about the group 7 is halogen because it produces salt. Salt producer. Right, Helen? For instance, if I say about sodium chloride. Ramit, can you tell me? Sodium chloride is an acid, base or salt?
I don't know.
Okay. Helen, what's that?
What is what? Acid?
Okay.
Huh? Wait, what's the question?
The question is, sodium chloride is acid, base or salt?
Salt.
Salt. Great. Your answer is absolutely correct. Ramit, it is a salt.
Okay.
You know that why I told you that one? Because if I say about the acid always having, not always, I can say in most of the cases, acid having hydrogen. And I was saying about the sodium chloride, right? It doesn't have hydrogen. So you cannot say that it is acidic. Okay, Ramit?
Yeah.
And if I say about the base, it should be OH negative, hydroxide ion. And in the sodium chloride, it's not the same. So still we can say that it's not a base. Then the third option is, which is left behind, that is a salt. Sodium chloride is a table salt. Table salt. Why am I saying? Because it's a salt. So whenever the group 7, Ramit, can you read that? Group 7?
Yeah.
Please.
What, group 7?
Yes.
It doesn't say anything on group 7. It says period numbers.
No, you have to read the elements.
Oh, okay. FR, RA, AC, RF, DB, SJ, BH, HS, MT, DS, RG, CN, MH, FL, MC, LV, TS, AG.
Okay. Helen, can you read that? Group 7?
Group 7. Okay. Fluorine, chlorine, bromine. I don't know what
Iodine.
Iodine.
Acetylene.
Yeah, I don't know. Yeah, I don't know TS either.
Okay. So why you both are having different answers?
Just gonna have a go.
Sure.
Fluorine, chlorine, bromine, iodine. I don't know how to say it, but acetylene and potassium.
Acetylene.
Yeah.
Ramit, you have read period 7. I was talking about the group 7. Group 7 is this one. Fluorine, chlorine, bromine, iodine, acetylene, and potassium.
Yeah.
And why it is known as halogen, that's what I'm saying. You have to focus it here. In today's class, I'm just observing. You are not focusing on that. Okay? Just try to focus because it's very important. Right? You're here to take a class. Don't waste it. You all have to focus it here. Okay? And I'll ask lots of questions from this topic. So you should have idea. So let's see. If I say about the salt producer, these all are known as salt producer because whenever it reacts with metals, it always forms salt. Okay? Let's see. Ramit, Helen and Nikita. If I react sodium with fluorine, okay, Na with F, it forms NaF. NaF is a salt. F is basically from group 7 and sodium is basically from group 1. So whenever the group 1 and group 7 is going to be react, you can say that, for instance, sodium and chloride. It would be sodium chloride. Right? Group 1 and group 7. So whenever any metal reacts with group 7, it always forms salt. That's why it is known as halogens. Okay? Okay?
Yeah.
And what's the group number 1, Ramit?
Lithium. That's one.
Great. Next one?
Na
Sodium.
is sodium. K is,
Potassium.
yeah. RB is, I don't know.
Rubidium.
Yeah. CS
Cesium.
is, yeah. And FR is one of them.
Francium.
Yeah.
Okay. So these all are the metals. Whenever it reacts with group 7, you can say that it always forms salt. Okay?
Mm-hmm.
That's why it is known as halogen, because halogen word means, you can say that salt produces. Halo means salt. And gen word means producer. So you can say that it always produces the salt. That's why it is known as halogen. Okay? Calcogen is basically because it always forms ores. Whenever you started doing digging and you'll get the metal. With the metal, we have some impurities. And overall, it is known as ores, right? So these ores generally having these non-metals, oxygen, sulfur, selenium, tellurium, polonium. We have lots of ores. For instance, if I say about the ore of copper, okay? The ore of copper is copper sulfide. Copper sulfide. Just a minute. Yes. Copper sulfide. Copper sulfide is an ore of copper. Okay? If I say about the iron, ore of iron is Fe2O3. Ramit, can you see that? In these ores, what is the last element? Sulfur here, oxygen here, right? And these elements are available in the group 6. Right? So whenever we have any compound which is having oxygen, sulfur, selenium, tellurium, polonium, the group 6 is available. So you can say that it is known as calcogen. Why so? Because it always forms ore. Okay? That's why it is known as calcogens. And the last one is the group number 5. The group 5 is known as picogens. Why it is known as picogen? Picogen word means suffocation. Have you heard about ammonia? Have you heard about ammonia gas?
Yeah.
Ammonia is also available in hair color. If generally we do hair color, in most of the cases, there's a very itchy smell, exactly. A pungent smell, you observe that. That smell exactly occurred due to the presence of ammonia. Why I'm saying? Because group 5, ammonia is NH3. NH3 is nitrogen. Phosphine is phosphorus. Whenever these elements are available in the gases, it always creates suffocation. So I can say that it is known as picogens. Because picogens word means suffocation. Okay? Did you understand?
Yeah.
Ramit?
Yeah.
Okay. So Ramit, what is the name of group 5?
Group 5 is called pictogram or pictogram.
Actually, yeah, we see the silent here. We say picogen. T.
Oh, okay.
T is the silent here. So picogen we say. Either if I spell it, it would be Pictogen. Okay? And the group 6 is known as, Nikki?
Do you have to say the group 6 names?
Yes.
Okay. It's oxygen.
No, you have to just tell me the name. As Ramit said, group 5 is picogen. So group 6 is?
Okay. Group 6 is just, I'll just say that one. Glycogen.
Yes. It's calcogen, right? Calcogen word means it forms ore. And what is the name of group 7? Helen?
Halogens.
Halogen. Why it's halogen?
Because it produces salt.
Exactly. If I say about the group 1 is always known as alkali metal. Do you know why? Because whenever you...
Reactive.
Yes, Nikki?
Because it's highly reactive.
What happened if I say about, yes, it's reactive, I completely agree. But why we say it's alkali metal? Because alkali word means base. Okay, Ramit? So whenever you react these elements with the water, it always forms base. For instance, I'll give you an example. Sodium with water. It will also always form sodium hydroxide. And sodium hydroxide is a base. Potassium with the water. It always forms potassium hydroxide. It's a base. Okay? So you can observe that each one is a base. Either sodium, either potassium, like that. So whenever we are dissolving these elements with the water, it always forms base or alkali. That's why it is known as alkali metal. Right, Ramit?
Yeah.
Okay. And what is the beautiful thing in this group? This group having one valence electron. Can you observe that? Each one having only one valence electron.
Yeah. I thought it was like it's because of the colors.
No, not exactly. You can see that. Pardon?
As like I thought you were like, what's the beautiful thing about that metals? So I'm like,
Oh, okay. You were observing the colors, but I haven't tell you colors, right? I'll just tell you in the next slide. Okay? Yes. So what exactly that? Each one having one valence electron in the last shell. And whenever we are heating that, it can easily lose one electron. That's why its oxidation state is +1. Lithium having +1, sodium having +1, valency +1, +1, +1, +1. Each group having +1 oxidation state. That's why we can say that it is known as alkali metal or group 1. Why is group 1? Because each one having +1 oxidation state. Do you understand?
Yeah.
Ramit is sleeping today.
No, I'm still awake.
Okay. So did you understand, Ramit? What exactly I explained?
Right now?
Yes.
Okay, you told us that the end valency of all of them is 1 because when it heats up, it burns that one atom and you need one more to like complete the shell.
Yes.
Yeah.
So we can say that it is known as group 1 because each one having +1 oxidation state. Okay, Ramit?
Yeah.
If I say about its valency, you can observe that if we have to make the compound, I have explained you, right? For instance, sodium and chlorine. Sodium having +1 and chlorine having -1, right? You can calculate it. The atomic number of sodium is 11 and the chlorine is 17. You know that its configuration is 281. One extra electron is there. That's why it has to lose. It's having +1. And if I say for the chlorine, it would be 287. It required one more electron. That's why it's having -1. And you have to cross multiply. You'll just neglect the -1 and the product will be sodium chloride. Am I correct? I suppose you have done that, right? We have already done this one. Right?
Sure.
Okay.
Sorry about Alexa anyways. Yeah, I do understand.
Okay. If I say about magnesium fluoride, do it fast. Now it's your turn. Be fast. Magnesium fluoride. Magnesium fluoride. Be fast. What's the answer?
Text.
Text. Be fast. Yes, Nikki? What do you have to do?
I just texted you.
You have to calculate the valency of each one. Be fast. You know the valency, right, Helen? Firstly, calculate the valency and you have to cross multiply it. What is the valency, Ramit, for the magnesium?
It's 2, 8, and then 2.
It's for magnesium, right?
Yeah.
And for fluorine?
Fluorine is 9, which equals to 2 and 7.
7. So, what's the valency? It's an electronic configuration, right? What's the valency of magnesium and the fluorine?
Magnesium, minus, plus 2.
Okay.
And for fluorine, it's going to be magnesium, minus 2.
It would be minus 1, right? Fluorine having 9.
Oh, yeah.
It's 2, 7. It required 1, right? You can
Yeah.
say that? That's what. So what would be the product? Whenever you have to cross multiply it.
I'm still kind of confused with the cross multiplying. How do you do that?
It's very easy.
You should.
Fluorine having minus 1 and the magnesium having plus 2. Then you have to cross multiply. So what do you have? You have to ignore the negative sign. Mg having 1 right now and fluorine having 2. So your product would be MgF2. Did you understand, Helen?
So where did the 1 go from magnesium?
No need to write that. I have written there to understand this one, but when you write the final product, no need to write that.
Oh, okay.
Ramit, did you understand this one?
Yes.
Okay. One more question I'm giving you. Be fast. You will have to write it. Lithium. Chloride. Be fast. Lithium having 3, fluorine having 17. What's the answer?
Is it lithium? Is plus you have to gain 1. Actually, they have to lose 1, so it's going to be lithium plus 1. And then chlorine, minus 2.
It's actually minus 1. I think it's minus 1.
Okay. Helen, are you sure it's minus 2?
Well, for chlorine, since it has 7 in the outer shell, you need to gain 2, so it's going to be minus 2.
No, you want to.
Oh, you did 1. You did 1.
So it will
Sorry,
be minus
yeah,
1. Ramit is saying absolutely correct.
Yeah.
And when you cross multiply, what would be your answer, Ramit?
I think it would be LiCO.
Great. It would be LiCO. Nikki, what happened?
How well?
Okay, you were busy somewhere, I suppose. Helen, is it clear? Is it clear to all of you? Okay. Now we are talking about the alkali metals. Nikki, sit here. Alkali metals are very soft metals. Okay? You can cut it by knife. You can easily cut it by knife.
It looks very satisfying when you see it inside. What happens?
In the metal?
In the metal, after you cut the metals, then you see a very shiny thing.
Yes.
And quickly fades away.
Metals are shiny, right? You can see the picture. Lithium, sodium, potassium, rubidium, francium. Each one is shiny. Right, Ramit? Helen? Nikki? Okay. So these are the soft metal. It can cut by the knife, and we preserve it in oil and or the kerosene oil. Why we preserve it? Because if we do not put these elements in the oil, it would react with the air and it started burning its own. That's why, to prevent it, what we do, we put these metals in the oil so that it should not be react with water, air or atmosphere, anything. Do you understand why we put in the kerosene oil or in the oil? Because it's quite reactive. It can easily react with water or air. So we want to prevent that. That's why what we have to do, we have to cover it, right? That's why we put these metals in the oil. Okay? The third point is it's quite reactive. Very reactive. Why it's very reactive? Because only one electron is in outermost shell. Right, Ramit? Each are having one electron. So it's very easy to lose one electron. That's why it's very reactive. Easy to lose one electron. Okay? Did you understand why it's reactive, Ramit? Helen? Nikki? Because each one having only one electron. It's very easy to lose one electron. Physical property. It's having low melting point. For cesium to lithium. Whereas other metals having higher melting point. If I say about these metals, right? These are the metals. And we have some other metals also. For instance, if I say about the iron. I hope you know that iron is very stronger. Right? You know that? Anyone having an idea? Iron stronger or the weaker? Can you break iron by your hand? No. That means it's hard, right?
Yeah.
And I told you, alkali metals are soft. You can cut it by knife. So whenever we compare the alkali metals by some other metals, for instance, transition metals. The example is iron. These metals are stronger. Okay? These metals are stronger and alkali metals are soft. Okay? Alkali metals are soft. You can see that. So here, as I told you, group 1 and the transition metals. If I say about these one, so we have to focus on the strength. And iron having stronger strength comparatively alkali. So if it's weaker, so it's having low melting point. Low melting point. It can easily melt. But if I say about the iron, iron is stronger. It's having high melting point. Did you understand the concept of melting point?
Yeah.
Okay. Ramit, did you understand?
Yeah.
So we can say that iron having 1540 degrees Celsius melting point and the alkali having very less. It's 28 degrees Celsius. It's very less. Right? Okay. The next one. If I say about its state, right? It can execute in solid, liquid and gas. In all the three states it's available. Okay? I can say it can be in the solid, it can be the liquid, it can be the gas. Now the most important reaction. You all have to observe it.
I think I just got a date.
Pardon?
I think I just got a date.
Okay.
I think I saw this video like somewhere in my school.
Definitely.
The season 1 is really funny because I'll really put it one go. Just it's bad. Like, I mean, it excellent.
Exactly.
Yeah.
You know that by this video, you can observe the reactivity. You can observe the reactivity of the metals. Right, Helen? Are you guys observing? If I say about the lithium and the cesium, which one is more reactive?
Cesium is more reactive.
Cesium is more reactive. It can easily explode, right?
Yeah.
Okay. So you can see that it can easily explode. Cesium is quite reactive. But if I say about the lithium is not much reactive, right? It's slow. What we are doing, we are putting these metals in the water. Because the reactivity of lithium is quite slow, so you can observe in the first year, it is going to be react with water and heat is going to be released. Right, Ramit, Helen, Nikki?
Yeah.
Okay. In the case of sodium, you can observe it's a little bit more reactive compared to lithium because it started burning in the presence of water. Right?
Yeah.
If I say for the potassium is more reactive than sodium because it started, you can observe the fire here. Very clear one. A crystal clear image. Right? Are you able to observe that or not? Okay. In the rubidium? What about the rubidium? Ramit, what about the rubidium?
Yeah.
It's more reactive, right? The lithium? Yes. And the last one is cesium. Cesium is most reactive. It can do a blast. Right? Right? Ramit, are you understanding?
Yes.
These elements having very less density, less than 1 gram per centimeter cube. That's why you can see that. You can say that can be cut by the knife. Because its density is very lesser, it can easily cut by the knife. Okay? It can easily cut with a knife. So you can say that its density is very lesser. Okay? Can you read that? Ramit, can you read that?
Yeah.
Please read this one.
The whole thing.
Yes, you have to just read the second statement.
Lithium, Na, which is
Sodium. Yes.
and potassium float on water, so they must have a density of less than 1 gram / centimeter cubed, because they can easily be cut with a knife.
Yes. So we can easily observe that, right? These elements can flow on water, its density is very lesser, it can easily cut by knife. Okay? Then if I say about the size, alkali metal size order. What is a size? Atomic size means the radius of an atom. Okay? The radius of an atom. If I say about its distance, can you observe that? Nucleus and the electrons. Right? The nucleus and the last electron. The distance from nucleus to last electron is known as atomic size. Or you can say that radius of an atom. If we move down to the group, its size increases. Are you able to see that cesium having bigger size comparatively lithium? Are you able to observe this? Why so? Because when you write the configuration, it would be 2-1, it would be 2-8-1, it would be 2-8-8-1, 2-8-8-18-1, 2-8-8-18-18-1. Are you guys observing? The number of shells increasing. 2, 3, 4, 5, 6. Are you observing that?
Yeah.
Helen, are you observing?
Yeah.
If number of shell increases, that means what? The distance from nucleus and the valence electron also increases. Right? The distance from nucleus and the valence electron also increases. So we can say that number of shell increases, distance from nucleus to valence electron increases, right? Am I correct? As well as because number of electrons increases, so repulsion increases. If repulsion increases, we can say that its atomic size increases. Okay? Is it fine, Helen? Ramit? Nikki? Anyone having any doubt?
No.
No. What about you, Nikki, Helen?
No.
No. So we can say that as we move down to the group, its atomic size increases. You can observe that. This one. Lithium, sodium, potassium. Okay, I just forgot to write hydrogen. Why haven't I write hydrogen? It's hydrogen, lithium, sodium, potassium, rubidium, cesium. That means if I move down, its size increases. Right? Okay? Okay.
Yeah.
Right, Nikki?
Yeah.
Okay. Just give me 1 second. Yes. So what you can observe here, if I say about, along the period, Nikki and Ramit. If I say along the period, for instance, yes, am I audible?
Yes.
Okay.
Yeah.
If I say along the period, its atomic size decreases. You know why? Because number of proton increases. I tell you how. I can write it here. See, the first one is lithium, then beryllium, then boron, then carbon, nitrogen, oxygen, fluorine, and neon. You guys have to focus it here, okay?
Yeah.
The lithium is 2-1. Beryllium is 2-2. Boron is 2-3. Carbon is 2-4. Nitrogen is 2-5. Okay? Oxygen is 2-6. Isra is also there, right? Isra? But Isra's mic is not working, I suppose. Even I'm not able to see you, Isra. It's 2-7. It's 2-8. Right? I hope you all know the electronic configuration, right? Ramit, Nikki, Helen. Okay. So, Helen, can you see that? Each one having only 2 shells. Can you count it? That means I can say that if each one having only 2 shells, that means number of shells are not increasing if I move horizontally. Right? Right, Ramit? Are you observing?
Yeah.
So I can say that number of shells are constant. Only atomic number increases. If atomic number increases, I can say proton increases. Proton increases means force of attraction increases. So I can say that its atomic size decreases. Okay? Did you understand?
Yes.
Its atomic size increases. Okay. Ramit, you can ask the question. I suppose you have one doubt, right? We were about to discuss that question.
Oh, what? The question on between the people.
Yes.
You want me to read you the question?
Yes.
That's fine. Let me find it.
Anyone having doubt in this one? Okay. Fine.
Do you want me to read it?
Yes.
So it said, in the periodic table, with transition elements and group 1 elements of metals, some of the properties of 2 transition elements and 2 group 1 elements are shown in the table below. And then it has the boiling point of chromium, iron, sodium, and calcium. And then it has the oxides. And it says, use your own knowledge and the data in the table above to compare the chemical and physical properties of transition elements and group 1 elements.
Okay, I tell you. Group 1 element is alkali metal, right? And transition elements are basically, you can say that it's the middle one elements. 2 properties you have to write. Group 1 are more reactive and transition elements are not more reactive. Because group 1 having only 1 valence electron. Right, Helen and Ramit? And the second one, group 1 are soft metals and transition metals are hard metals. Okay? Did you understand, Helen? Did you understand, Ramit? So these are the physical property which you have to write for this question. Only 2 properties you have to mention. Even we have lots of, but for this question we require only 2. Any doubt? Did you understand? Ramit?
Yeah.
Helen, did you understand? Okay. Now I'm just going to wind up the class. In next class, we'll discuss the remaining things. Okay? Okay then. Bye-bye. Have a nice day.